Good morning, students. So we will continue our discussion of media access control or medium access control and its methods. So, as you know, we discussed the problem of hidden and exposed terminal, and in media access control, always a station before transmitting any data senses the medium. If the medium is free, it transmits. Otherwise, it waits for a random amount of time before it senses again. If the medium is free, it go ahead and transmit. Otherwise, it again waits. Okay, so there are two types of method as we discussed, that is CDMA, CD, and CSMA, CSMA CD, and CSMA CA. So what is CSMA-CD? CSMA-CD is carrier sense multiple access which with collision detection. This is CSMA-CA means carrier sense multiple access with collision avoidance. Okay. Here we can detect the collision, but we cannot avoid the collision. But here we can avoid the collision as well. So what is the idea behind CSMA-CD is that first, a station which wants to transmit data always senses the medium, whether it is free or not. If it is free, it will transmit, as I said. Otherwise, it waits for some amount of time before it attempts to transmit again. Now, as the name suggests that it can detect collision. How it can detect collision is the question. Suppose this is the medium, okay, and we have various stations connected. Now suppose the station A wants to sense to station B. Now it may so happen that while transmitting, now this station C may also want to send data. Now this will result in interference or collision if while the station is busy, the C will transmit. So that's why what happens is in carrier sense multiple access, before sending any data, C will sense the channel first. So when C senses the channel, it will get to know that no, channel is busy, I shall wait. Okay? Channel is busy and C will wait. Okay? So this way collision will not happen. But if the channel is, if the medium is heavily connected with nodes, suppose the medium has 100 stations connected to it. Okay? If it has 100 stations connected to it, what may happen is while sending data to A, C and this is D, suppose D may want to send data to B as well. Now it will sense the channel. Now it will find that the medium is free. So it will simply go ahead and starts transmitting. And when it starts transmitting, collision will happen. Okay. Now, we also can detect the collision in this case, in CSMA-CD case. How? I will explain this scenario in greater detail now. Okay? Now, the players are A, this is C, this is B, and this is D. A is transmitting data to B. B senses the carrier and finds that it is channel is free, so it sends data to B. Now collision will definitely happen. Why? Because B is busy and at the same time D is sending data to B. So collision will happen definitely. But how to detect that collision is always in CSMA-CD the transmission delay or the transmission time is greater than equal to round trip time, RTT. Now what is round trip time? Round trip time is the time to send a signal and to get back a reply. Okay, that is the time. That is, what is the time to propagate a channel? Propagate a signal in the channel. That is, suppose it is T1. Time for propagation. TP is suppose T1. T1 is the time for data to reach from D to B. That is the time. Time for signal to reach from D to B, isn't it? You have already studied all this in computer networks. What is propagation delay? What is transmission delay? Transmission delay is the time to transmit the data into the channel. Okay, the time for the node or for the station to transmit the data from itself into the channel is what called transmission delay. Now, the idea is how to detect the collision is, suppose this travels to B and the time to reach from B to D collided signal, it can, D can sense that collision is happening when it is in transmission, when it is still transmitting. If it is still transmitting and it gets the data back, the collided data back, then D will come to know that collision has happened. Okay? So D will get to know that collision is happening. This is only possible when the return signal, when it comes, if D is still transmitting. If D is still transmitting while getting the collided signal back, then D can make sure that yes, collision has happened. Okay, if D is not transmitting and a collided signal comes back, then D will never get to know that its own signal has collided or not. It will simply sense that the carrier is busy maybe. But if it is transmitting and it gets back the collided signal, then D will be sure that yes, my signal which I had sent has been collided. That is called collision detection. That's why we say transmission time must be greater than or equal to the round trip time. Round trip time means the time for signal to reach to B and from B to come back to D. That is called round trip time. Okay, I hope you got it. How it is able to detect the signal. This condition must be true for CSMACD to work. Okay. Now coming to CSMACD. This can not only detect the collision, but it also works towards avoiding the collision. It does something extra so that the chances of collision will be minimal, so that collision may not even happen. Okay, for that matter it does something extra. What extra does it do? Suppose this is the medium and we have two station A, let's keep it simple, and a station B. This is the medium. Now, before sending data, as usual in CSMA, carrier sends multiple access, one will sense the medium, whether it is busy or not. If the carrier is busy, it won't send the data, and if the carrier is free or the channel is free, it will simply send the data. Okay. Now, suppose A wants to send data to B. It will sense the channel, whether the channel is busy or not. Now, even though the channel is free, what A will do? A will send a packet called request to send. It will send a packet called request to send. Request to send means that A is requesting B that it is letting B know that see B, I want to send data to you. Are you free? Are you available? Just tell me whether you are free or not. Then only I will send the data, because I don't trust the channel. Although the channel seems free, but still I don't want to send data to you. I want an answer from you only, whether you are free or not. This is what done in collision avoidance technique. So RTS request to send. Now, if B is actually free, it is really free, then B will reply with clear to send packet. Now, what is clear to send? Clear to send means B says, see, I am now free, you can send me data. If it is not free, it won't send clear to send. Okay? If B is not free, B will not reply with CTS packet. Okay? If this A doesn't get the CTS packet, it will not go ahead with the transmission. Okay? Only if we get a CTS packet from B, it will go ahead and start transmitting its signal to B, or communication takes place then only. Otherwise, communication is stopped. Again, A, if it doesn't get the CTS, if A doesn't get the CTS, it will again wait for random amount of time. Then again it will sense the carrier. If the carrier is free, then again it will send an RTS to B to see if B is now free or not. This process continues so that collision is reduced substantially. Okay. In this case, in CSMA, collision is reduced to a very substantial level. The collision is, very less, because here not only we can detect the signal, detect the collision, but we can also avoid the collision. Okay. Now, we will discuss about what are the various access methods in terms of resource, how we can use the resource so that, multiple devices can access a single channel. Okay. So now, we have already discussed multiplexing techniques. Okay. So those multiplexing techniques are also applicable in multiple access control, because the idea is same. How to use a single channel, how to make use a single channel by multiple devices. How multiple devices can use a single channel is the idea, is the question. So the access methods are usually what we have studied: space division multiple access, okay, then time division multiple access, we have frequency division multiple access, and we have code division multiple access. Okay, so these are the four major, multiple access techniques. How a medium, a resource can be used by multiple devices for communication, for effective communication. Okay, what happens in SDMA is we, divide the space. We divide the space and we give the space to a proper device. Suppose there are three devices, the entire space is divided into three sections, and each device uses that space, that is the wireless area, to communicate to different other devices, to receiving devices. What is TDMA? TDMA means time is divided. Suppose this is the time. So T1 is given to a device called D1. T2 is divided. Slot 2 is given to a device called D2. Slot 3, T3 is divided. This duration is given to a different device. So at these times only they can communicate. T1 can always communicate in time. Suppose there are 24 hours. Just giving a simple example. Now we can divide it into 8 hours. Okay, 3 8 hours. Now in first 8 hours, suppose device 1 will communicate always. In next 8 hours, suppose D2 will communicate always. In next 8 hours, T3 will communicate. And this cycle repeats. This is called somewhat time division multiplexing, in which we divide the time and each slot is given to a particular device, and we say that, see, you always communicated this time only. Okay. So that is called time division multiple access. Similarly, frequency. In frequency division multiple access, the entire frequency band is divided. Suppose the frequency is 500 kilohertz. We divided somehow. Suppose 200, this is 150, and some 150. Suppose this is how we divide it. Okay. So this frequency is given to device 1. This frequency is CDMA means we code the signal. Okay, each device's signal is coded. So here we use spread spectrum (SS). We studied it in the last class, I guess. We studied about spread spectrum, in which the frequency is broadened. The frequency is same. The entire frequency is used by the multiple devices, but in a codified fashion. We generate a pseudo random generator in which we codify the signal, so that it is very much secure. There is no chances of interference, and at the same time we can distinguish. We can distinguish that what is the signal of which device. How? Because they are codified. And at the receiving end, we can apply the key or the pseudo-random generator of the receiver. It acts like a key, right? If we codify, if we encode it using the, if we encode it with a particular key, then the receiver can also decode it. Okay. So every device's signal are coded in a unique manner, and at the receiving end, it can apply again the key to decode it and extract the signal. Okay. So this is how CDMA works. Okay. So I think we completed medium access control. Okay. In the next class, we will start with wireless LAN. Okay. WLAN we will start. That is, the protocol name is 802.11. We call it Wi-Fi. Okay. So we will discuss about wireless technology. What is the infrastructure of wireless technology in the next class. Meanwhile, in case of medium access control, if you have any doubt, you can post it in the comment section, or you can directly contact me via WhatsApp.